Good morning, children. Now we'll continue with the problems. As you already know, to find the differential equation when solution is given, you must see in the solution how many arbitrary constants or parameters are there. So many times you have to differentiate and then you must eliminate the parameters or arbitrary constants. So in this problem, form a differential equation corresponding to the family of circles of radius r. Radius r is not a parameter here. Radius is fixed. Centers are changing. X minus a whole square plus y minus b whole square is equal to r square, where a and b are parameters. So what we do is we are given x minus a whole square plus y minus b whole square is equal to r square, where a and b are arbitrary constants. A and b are parameters. So that means you must differentiate twice successively. So first we'll differentiate with respect to x. We'll number this equation as 1. Now differentiating with respect to x. So what is the derivative of x minus a whole square? And then derivative of y minus b whole square is equal to the derivative of r square. Radius is fixed, so it is a constant and its derivative is 0. Now this is in the form x to the power n. So the derivative is n into x to the power n minus 1, 2 minus 1, that is 1, into the derivative of x minus a, 2 minus 1, plus derivative of y minus b. Here the variable is different. Anyhow, it is a square. So 2 into y minus b. Derivative of y minus b whole square is 2 into y minus b into the derivative of y minus b is equal to 0. So now what happens? Derivative of x is 1. Derivative of a is constant. So it is 0. Similarly, derivative of y is 1 into dy by dx. Derivative of constant b is 0. So that means you will get 2 into x minus a whole square into 1 plus 2 into y minus b into dy by dx is equal to 0. Now you can take 2 common and cancel. So 2 minus 1. So this is 1. 2 into x minus a whole to the power 2 minus 1, that is 1. So you can take 2 common and cancel. So x minus a plus y minus b into dy by dx is equal to 0. So this is the second equation. From this we'll find out x minus a. So x minus a is equal to minus of y minus b into dy by dx. Now we'll take this as second equation. Now again you have to differentiate this. So when you differentiate again you will get another equation and you must eliminate a and b. So what we do is you can find the third equation and then eliminate. That may become a lengthy process. So what we'll do is we'll substitute x minus a value in the first equation. Then you will have only one arbitrary constant b. So we'll substitute and see how it is simplified. Substituting in 1. Substituting in 1, equation 1, we get, substituting in equation 1, we get x minus a whole square. So this whole square. So that means minus of y minus b dy by dx whole square. Whole square plus y minus b whole square is equal to r square. Is equal to r square. Now when you square this, it is minus 1 whole square is plus 1. So y minus b whole square into dy by dx whole square. So that means it is y minus b whole square into dy by dx whole square plus y minus b whole square is equal to r square. Is equal to r square. From these two, we'll take y minus b whole square common. So when we take y minus b whole square common, it is, so it implies, okay, y minus b whole square into this I will write as y1. dy by dx is y1. So y1 square plus 1. So y1 square plus 1 is equal to r square. So this is your equation. Now we'll differentiate. Differentiate with respect to x. We must differentiate this equation 2 times with respect to x. Here we differentiated only one time and we simplified. We substituted that in the first equation and we got that equation. Now we'll again differentiate. Now this is in the form uv. Derivative of uv is first function into the derivative of second function. So y1 square plus 1 plus second function into derivative of first function. So that means d by dx of y minus b whole square is equal to the derivative of r square. D by dx of r square, that is 0. So now what is the derivative of y1 square? Derivative of y1 square is 2y1 into derivative of y1, that is y2. So y minus b whole square into 2y1 y2 plus y1 square plus 1 into, again the derivative of this is 2 into y minus b into derivative of y, that is y1 is equal to 0. Derivative of r square is 0. So derivative of y1 square is 2y1 into derivative of y1, that is y2. I discussed all this in the first period. Okay. Now in the same way here 2 into derivative of y minus b whole square, here we did in the same way. Now from these two, all this you can take 2 into y minus b into y1 common. 2y1 into y minus b common. Then what is left here? Y minus b into y2. So y minus b into y2, and here 2 y minus b, y1 common. So y1 square plus 1 plus y1 square plus 1 is equal to 0. So this cannot be 0, so it has to be this 0. So this implies y minus b into y2 plus y1 square plus 1 is equal to 0. From this we'll find out y minus b. So y minus b is equal to minus y1 minus of y1 square plus 1 by y2. So you take y1 square 1 that side, so it becomes minus of y1 square plus 1 divided by y2. Now this is y minus b. Now we will find out x minus a also in terms of this. So from equation 2 you will get, y x minus a is equal to, so x minus a is equal to, so this is equation 3. Okay. Now x minus a is equal to minus of y minus b. So what is minus of y minus b? So y1 square plus 1 by y2. Minus of y minus b into dy by dx, that is y1. So we'll write into y1. Now this is x minus a and this is x minus b. Now substitute 3 and 4 in the first equation. Then both a and b will get eliminated. So I'll write here substituting 3 and 4 values in 1. Substituting in 1 we get x minus a whole square means what? y1 plus 1 by y2 whole square into y1 square, x minus a whole square, plus y minus b whole square is, you square this. When you square this, it becomes y1 square plus 1 whole square by y2 square is equal to r square. Now you can see y2 square is the LCM, denominator is the same. So I'll have y1 plus 1 whole square by y2 square. If you take common, then it is y1 square, here y1 square, and here y1 square plus 1 whole square by y2 square you have taken common. So only 1 is left, is equal to r square. So now it is again the same thing, 1 plus y1 square only. So that means it is y1 square plus 1 whole square. This is y1 square plus 1. y1 square plus 1 whole square. So y1 square plus 1 whole cube. This is 2 times and this is 1 time, 3 times. By y2 square is equal to r square. So that means y1 square plus 1 whole cube is equal to r square into y2 square. Now you write always after writing the equation in terms of y1, y2, so on. The final equation you write in terms of dy by dx. What is y1? Dy by dx. So dy by dx whole square plus 1 whole cube is equal to r square into y2 square means d square y by dx square whole square. D square y by dx square whole square is the required differential equation. So this is the required differential equation. This is very lengthy and still little bit important. So first you are given this equation, you are differentiating. So these steps, a few steps you can avoid. You can directly write the derivative. You can directly write this step. You need not write all these steps. So you will get this derivative and then x minus a, then find x minus a and then substitute in the equation, first equation. Then you will get the equation in terms of y minus b. So y minus b whole square into, this is y1 square. dy by dx I wrote as y1 square. And then it is y minus b into y1 square plus 1 is equal to r square. Then again differentiate. This is in the form uv. First function into derivative of second function plus second function into derivative of first function. So derivative of r square is 0. So again you will get like this. So it is equal to y1 square x minus a and then yes minus of y1 square plus 1 when you take it to this side. So x minus a, substitute here and simplify, you will get like this. Okay. Now we'll do the next problem. Okay, form a differential equation corresponding to the family of circles passing through the origin. Family of circles passing through the origin and having centers on, this is second problem, and having centers on y-axis. So we know that the general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, where g, f, c are parameters. Now it is passing through origin. It passes through origin. So what is c? It passes through origin implies c is equal to 0. So c is equal to 0. Now the centers are on y-axis. What is the center? Center is minus g minus f. Minus g minus f lies on y-axis. So on y-axis we know that x coordinate is 0. So that means g is equal to 0. So g and c are zeros. So therefore the family of circles passing through origin, and centers on and having centers on y-axis. So the circles passing through origin and centers on y-axis are of the form x square plus y square plus 2fy is equal to 0, where f is the parameter. Now what you do, you have only one parameter, so you will differentiate only once. So differentiating with respect to x. You will get, what is the derivative of x square? 2x. Derivative of y square is 2y dy by dx plus 2f into derivative of y is 1 into dy by dx is equal to 0. Now solve this is for, you can take 2 common and then 2 you can take common, x plus y plus f into dy by dx is equal to 0. You take dy by dx common, then 2 also common. So the right side it is 0. So 2 will go. So you'll have x plus y plus f into dy by dx is equal to 0. Now you need f to eliminate f, the arbitrary constant. You find out f from this and substitute here. That's all. So y plus f into dy by dx. I'll write dy by dx as 1, y1. Then it is easy to write that steps is equal to minus x. So that means y plus f is equal to, I'll write here, implies y plus f is equal to minus x by y1. So that means f is equal to minus x by y1 minus 1. Now substituting in equation 1, we get x square plus y square plus 2fy. Multiply this by 2y. 2y into f. F is this. So minus x by y1 minus y is equal to 0. Now simplifying, you'll get x square plus y square plus minus 2xy by y1 minus 2y square is equal to 0. X square, this y square will go, so it is x square minus y square is equal to, you take this term to that side, then it becomes 2xy by y1. Now bring y1 to this side. That becomes the equation. So it means x square minus y square into y1 is equal to 2xy. So this y1 should not be in the denominator. It should be written as a polynomial equation in the derivatives. So x minus y square into y1 you write now as dy by dx is equal to 2xy is the required differential equation. So this y1 should not be there in the denominator. It should come to the numerator. So cross multiplying, simplifying, you'll get like this. So first write what is that family of circles according to the given conditions. So it has just reduced to this form by g is equal to 0 and f is equal to 0, c is equal to 0, g is equal to 0 and c is equal to 0. So only f is the parameter. So differentiate only once, find out f and eliminate f. So this is the required differential equation. Form differential equation to the family of following curves. So in this we'll do this problem. Third problem, the ellipses with centers at the origin. Centers at the origin and having coordinate axis as axis So you have not, in ellipse we have the standard equation of the ellipse as x square by a square plus y square. The standard equation of the ellipse. The standard equation of the ellipse with the center as origin is x square by a square plus y square by b square is equal to 1. So this is the equation whose centers are origin and the coordinate axis are the axis. So now you have two arbitrary constants here. A and B are parameters. So that means you must differentiate 2 times with respect to x. So what you do is, first we'll write the equation as b square x square plus a square y square is equal to a square b square. Take LCM as a square b square, cross multiply, you'll get it. Then it is easy for us, because when you have constants in the denominator, we may get confused in writing the derivatives. So this is your equation 1. Now differentiating with respect to x, you must differentiate 2 times. So first time you are differentiating with respect to x, we get derivative of x square. Derivative of x square is 2x plus a square into derivative of y square is 2y into dy by dx. And derivative of a square b square is 0. So from this you can take 2 common. 2 into b square x plus a square y. I'll write dy by dx as y1 is equal to 0. So that means b square x plus a square y1 is equal to 0. Now we'll take this as second equation. But see, here we have two constants in two terms. So another idea of eliminating a and b from this equation itself without substituting anywhere else, we can do like this. See, b square x, or else I'll take b square x to that side. So a square y1 is equal to minus b square x. Okay. Now we'll take a square to that side, and x to this side. So y1 by x is equal to minus b square by a square. So all constants are on one side. Then what happens when you differentiate this equation? Now this becomes, derivative of this becomes 0. But here you have to use u by v rule, quotient rule. Okay. Now again differentiating with respect to x. So the derivative of this is denominator into the derivative of numerator minus numerator into the derivative of denominator by denominator square, x square, is equal to the derivative of minus b square by a square, which is a constant. So its derivative is 0. Now here the only difficulty is here. This is in the form uv. First function into derivative of second function plus second function into derivative of first function. So those steps you have to write properly. Okay, so it implies x into first function into derivative of y1 is y2 plus second function, that is y1 into derivative of first function. Okay, otherwise I'll write like this. See, first function into derivative of second function plus second function into the derivative of first function, that is y, minus y1 into derivative of x. Derivative of x is 1. So into 1 by x square is equal to 0. So when you cross multiply, that becomes 0 only. So that means x into y into derivative of y1 is y2 plus y1 into derivative of y. Derivative of y is dy by dx, that is again y1, minus y1 is equal to 0. That's all. So both a and b got eliminated. So I'll get the equation as xy2 plus xy1 square minus y1 is equal to 0. Now write the equation in terms of d square y by dx square dy by dx. y2 is d square y by dx square. y1 is dy by dx whole square minus y into dy by dx is equal to 0 is the required differential equation. So this is the required differential equation. Now we'll do this problem. Y is equal to a cos 3x plus b sin 3x, because there are two arbitrary constants. A and b are the arbitrary constants. A, b are the parameters. We must differentiate 2 times. So differentiating with respect to x. Dy by dx is equal to a into derivative of cos 3x. Plus b into the derivative of sin 3x. Now what is the derivative of cos 3x? Outer function is cos. Derivative of cos x is minus sin x. So minus sin 3x into the derivative of 3x. Plus b into derivative of sin 3x is cos 3x into the derivative of 3x. The derivative of 3x is 3. So that means dy by dx is equal to minus a sin 3x into 3. So into 3. I'll write 3 here, minus 3a. Plus again this is 3, so 3b into cos 3x. So this is the first equation and this is the second equation. Now again differentiating with respect to x, because there are two arbitrary constants. So again differentiating with respect to x, we get derivative of dy by dx is d square y by dx square is equal to minus 3a into derivative of sin 3x. Derivative of sin 3x is cos 3x into derivative of 3x. So cos 3x into 3 plus 3b into derivative of cos 3x, that is minus sin 3x into 3. So now you can see, you can take 9 common. You can even take minus 1 common. So minus 9 into a cos 3x plus b sin 3x. B sin 3x. This is nothing but our y from equation 1. So this is minus 9y. So that means so a and b got eliminated. So d square y by dx square plus 9y is equal to 0 is the required differential equation. So this problem we solved, but there was a mistake in here. I made mistake. So this is the correct solution. You can just correct yourself. And then this is the homework. The parabolas, each of which has a lattice rectum 4a and whose axes are parallel to x-axis. When the axes are parallel to x-axis, this is the equation. He has given the lattice rectum as 4a. So a is not a parameter. H and k are parameters. A is fixed, lattice rectum. So this is your equation like this. So you must differentiate 2 times. So finally you will get the answer like this. 2a into y2 means d square y by dx square plus y1 cube means dy by dx whole cube is equal to 0. This is your answer. Okay, now we'll continue with the problems in the next video.